Hi, my name is Jason Lowe, and I'm a lead water treatment plant operator at Placer County Water Agency. And today I'm going to be giving you a tour of the Foothill Water Treatment Plant located in Placer County, California. Before we start this tour, I'd like to point out that we're using a 360-degree video tour format throughout this tour, which will allow you to click anywhere on the screen and give you a 360-degree view of any of the treatment process that we walk through today. So let me start off with our two raw water sources. Where do we get our water? First off, Lake Spalding, which is located roughly 54 miles north of the treatment plant, and that water flows through a PG&E canal system to the plant. Secondly, we have the American River, which allows us to pump from the American River pump station to our Ophir pump station, which in turn pumps into the PG&E canal system to the water treatment plant. I'm standing on our trash rake structure, which is the first step in the treatment process here at the Foothill Water Treatment Plant. If you look behind me, you'll see it's running right now, and it's designed primarily to remove any large sticks, smaller sticks, leaves, anything floating in the water that comes through. This trash rake will remove a majority of it. If you look to my left, you'll see where the water is flowing through the canal to the trash rake structure. From here, it goes to our grit structure at the Foothill Water Treatment Plant, and that's where we're going to be going next in this tour. So here we are in the grit structure. A grit structure is primarily designed to remove any sand, small pebbles, sticks, leaves that flow into this process. If you look behind me, you see this water bubbling over. This is the inlet to the grit structure. That water then flows underneath me to these two sides. If you follow me to this side, you'll see that the water is creating a vortex in here. Well, there's a paddle shaft mixer that's vertically spinning that water to help any of the heavier objects settle out before it moves on through the process. So once it gets through this stage, it goes on to our screen system, which basically acts like a polishing system. It's removing any of the leftovers, small sticks, leaves, algae that get through this process before we go to the next step in the treatment process. I did want to point out, if you look where I'm pointing right now, this is the rest of the Foothill Water Treatment Plant, and we currently have two treatment plants on site. Plant 1 is a 42 million gallon per day active flow treatment plant. Plant 2 is a 21 million gallon per day conventional treatment plant. And as we go through these next stages in the tour, we'll explain these treatment processes in depth. And let's go ahead and head this way and go on to our next treatment process. So here we are at Plant 1, which is a 42 million gallon per day active flow water treatment plant. Originally, Plant 1 was a 12 million gallon per day conventional water treatment plant that was built in 1979, then was upgraded to the 42 MGD active flow water treatment process. So in the active flow water treatment plant, there's 4 stages. The first stage is coagulation. In the coagulation stage, raw water is introduced and a coagulant is added. And then as it flows through the coagulation stage, it moves on to an injection stage. In the injection stage, micro sand is added along with the polymer, and then from that stage it flows to the maturation stage, which you see down here below me. This area allows for the particles, the sand, and the chemicals to bind together in this area as it flows towards clarification. Once it goes to clarification, down below here to my right, there's a big scraper that's spinning around in circles, which collects all the sand and the sludge that settle out in this zone. From there, it's pumped back through this line behind me to a hydrocyclone, where the sludge is removed going out the top to our sludge ponds, and the sand is reintroduced back into our injection zone. That's created by a high vortex velocity through the hydrocyclone. And what we use the hydrocyclone for is to measure the sand in the water to allow us to know how much sand we need to add or introduce to treat the water in this process. And then from here, after it flows through underneath this part of the clarification, the water flows through these weirs and out to our filters. So now we're going to go outside and we're going to discuss the filters here on Plant 1. So here we are in the next step of the treatment process, which is filtration. Behind me and in front of me are 9 filters for the 42 MGD active flow treatment process. Filtration is one of the key elements in water treatment, and as that water flows through and out of the active flow plant, comes through these filters and flows through a bed of anthracite and sand through an underdrain system, and the filters are designed to move any particles in the water that are harmful for consumption. Once it flows through these filters, then we add sodium hypochlorite for disinfection, and then it moves on to our 10 million gallon and 1 million gallon storage clear wells. And then from this point, we're going to go ahead and head over to Plant 2, and our treatment plant operator, Lindsey, is going to give us a tour and explain a little bit more about filtration and that process.
Hi, my name is Lindsey, and I'm a treatment plant operator with Placer County Water Agency. We are here at our Foothill location, and I'm going to give you a tour of our Plant 2 conventional water treatment plant. A conventional water treatment plant involves coagulation, flocculation, sedimentation, and filtration. Plant 2 was originally built in 1989 as a 15 million gallon per day plant. And over the last several years, we've done improvements and projects, and now it's rated at 21 million gallons per day. If you take a look behind me, you'll notice that the grit structure that Jason previously gave you the tour of. So from the grit, after the raw water has been screened, it is piped underground and enters the plant from this point. Here is where we add our main coagulant and our coagulant aid, and those are rapidly mixed with our rapid mix or flash mix, and they're evenly distributed throughout the water. This process is also called coagulation. So a positive charge from our coagulant neutralizes the negative charge of the dissolved and suspended particles in the raw water, and they attract each other like a magnet. So those particles are able to bind and form larger particles that we can settle out in this process. So from here, it splits into two parallel flocculation sedimentation basin trains, and I'm going to walk you through these next steps. So I'm standing on our walkway suspended above our flocculation basins. So flocculation is also known as gentle mixing. It's taking those smaller particles that we discussed in the coagulation process to form larger particles that can settle out, also known as floc. Our flocculation basin is broken up into 3 different chambers. We have a tapered mixing. So in this first chamber, it's going to have the fastest mixing speed, and as we move towards the sedimentation basin, the mixing is going to slow down. I'm going to discuss the flow of water on how it goes through the flocculation basins. So in this first chamber, as it comes from the rapid mix, it's going to enter this first chamber. It's going to go underneath the baffle wall that you cannot see into this next chamber. It's going to go over this next baffle wall into the last chamber, which is also the slowest mixing speed. This last baffle wall before the sedimentation basin has perforated holes that evenly distribute the water into the sedimentation basin. And let's go talk about that process. As the water leaves the flocculation chambers through the last baffle wall, it enters our sedimentation basins. In the sedimentation process, we're reducing the velocity of the water to allow the suspended material and the floc that we discussed earlier to be settled out by gravity. Those larger particles settle to the bottom of the basin, and this is something that we also call sludge. Over here we have our chain and flight system. This moves very slowly across the floor of the basin and collects the sludge into a collector trough. There's an auger that spins and a waste valve that is controlled by a timer that opens to allow the sludge to be removed from the basin. During our peak demand months in summer, the consumption of water is a lot higher, so we are flowing at our highest flow. We're at 21 million gallons per day. In that time, we are removing about 270 pounds of waste and sludge on average each day, making the water safer for human consumption. During those summer months when our water consumption is at the highest, like I mentioned, we're flowing at 21 million gallons per day. That's also equivalent to 14,580 gallons per minute, or an average size swimming pool being filled every minute. So it takes about an hour for the water to flow from the inlet of the basin to this end. The water is going to flow up through these plate settlers that you're seeing the tops of over here. It flows up through the plate settlers, and the clarified water is flowing over the launders into the collection trough. From there, the water goes into the influent filter channel, and we'll talk about that later. So the plate settlers are actually placed at a 55 to 60 degree angle, and they're stacked, one on top of the other, with enough room to allow the flow of water to go up. So what the plate settlers are doing are increasing the effective settling area of our sedimentation basin. The solids and the floc that we've been talking about agglomerate on the plate settlers. They gain weight, and then they actually slide down. So that sludge slides down and lands at the bottom of the basin, where the chain and flight system that I mentioned before is going to take that all the way down to the collector trough and remove that from our basin. So from here, we actually move into our filter area, and I'm going to talk about filtration next. As the water leaves the sedimentation basin, It flows into this common filter influent channel. So if you take a look, you can see the water flowing below you. So at this point, we're adding our disinfectant, or sodium hypochlorite. While filtration can be 99% effective at removing harmful organisms in the water, disinfection is a really important process to make sure that we are inactivating or killing any remaining organisms in the water to make it safe drinking water. At this point, we're going to move on to our filters and we're going to show you the process. So here we are at the filters. We have 4 filters at Plant 2. The filtering is actually happening below the surface of the water. So in gravity filtration, the weight or the pressure of the water is forcing the water through the filter media, which consists of sand and anthracite. To give you a visual, underneath the water, this is what is being strained through. So we have our layer of anthracite, and then we have a layer of sand underneath. So the water is actually being forced through and strained through this media, and by the process of micro-straining and also adsorption, or the process of gathering material on the surface of another material, we are able to filter out all those suspended and any leftover organisms. After this process, it goes from the clear well and then to the distribution system. So, and just to give you an idea, we're actually having a backwash happening right here. So if you kind of point the camera down, you can see the process of our air wash right now, just to give you a visual. So this is the basement of Plant 2. This is our filter piping gallery. So on this side is my sedimentation basin. This is the end wall. Right on the other side would be those plate settlers that we discussed. And then over here is our filter area. So if you take a look up, you can actually get an idea of how deep the basin and filter area is. So down here, we're gonna have different sample lines for monitoring. We're gonna have chemical lines, different piping and valving. This is gonna be filter to waste, wash water, and then most importantly, the filter effluent. So that filter effluent piping is actually carrying that clean drinking water to the clear well. Most of our instruments can also be found down here too, and those instruments are used for monitoring. So we have our chlorine analyzer, which is going to be monitoring the disinfectant residual going to the clear well. We have our temperature and then our pH. So the pH is measuring more of the health of the water. So it's going to tell us if the water is too acidic or the pH is too low, or if the water is too basic or the pH is too high. So this will let us know in the treatment process if we need to make adjustments. We also have our turbidimeter. So we do have individual turbidimeters at each filter, but I'm going to be talking about the combined filter turbidimeter. So a turbidimeter is measuring the turbidity of the water, or the cloudiness or the clarity of the water. This is going to be showing us water quality and also our filtration effectiveness. So from here is where it goes to the clear well, and then Jason's going to touch on the distribution system in a little bit.
So here I am standing between our 2 storage tanks. To my right is a 1 million gallon storage tank. To my left is a 10 million gallon storage tank. The 1 million is primary use for backwash and filters at the plant, and or if maintenance is needed, we can isolate the 10 million and utilize the 1 million gallon storage tank. If you look at this 10 million gallon tank, it's 10 million gallons of water. It's a lot of water, and this is what feeds our consumers for PCWA. So once it leaves this tank, it's in the distribution system right to your tap. That concludes our tour. I hope you enjoyed it. Thank you for joining us, and feel free to follow us on social media and or PCWA.net. Thank you.